Hi, everybody. So I just launched a new small ASO tool. Um, the tool is, you can call it app rating simulator, or maybe better, like a crisis simulator. So the idea behind this is like two things, right? So one thing is like sometimes or usually, I don't know, I would like to know how much it will take for an app to achieve a certain displayed rating, right? So how much time at the current pace of the amount of ratings they get and the average rating that they have in this recent period. Um, or the other way around. I mean, what would it take for the rating to drop significantly? So kind of these are the two things. I mean, these are one thing, and the second thing is that I want to simulate a crisis. Like for example, if you get a bad PR piece published about you, or you get some bugs and your release, your version that you released, is having some like a lot of I don't know, UI problems and functionality issues, and users complain, and you have this crisis and your rating drops. So I would like to know how low can it drop, assuming a certain amount of reviews, and also what would it take to recover the displayed rating, or to recover even the average rating. So this is what this tool is about, is like a calculator, like a simulator slash calculator that you can use. So to use the tool, you go to our website, topanda.co, and here you have tools. There are all the other tools that I have. Like, usually we talk about the keyword research tool and the metadata optimization tool, but I have also a visibility viewer. And now we're going to show you I'm going to demonstrate the app rating simulator. So you go to app rating simulator, and here it is. So first of all, you can play with any kind of numbers that you want, okay? Or you can insert an app, like your app, other app, and it will just fetch the publicly available amount of ratings and the average rating score in the specific location. So sometimes I'm going to say reviews, I mean ratings, right? So reviews, kind of written reviews, but this is not about written reviews. This is about total rating or stars that you get. So if I say reviews, I mean rating. So that's all it's going to do. It's just going to fetch this data from the app that you're going to provide here. Um, Now, it is for App Store and for Google Play, but there are differences. There are two main differences in how review ratings are calculated and presented, displayed to users in both stores. So the two main differences is, first of all, the displayed rating. So in Apple App Store, in order for your app to show 4.8, right, you need to have a rating of at least 4.7. So you get to 4.75. So you get to 475, you start showing 4.8. In Play Store, it's a little bit easier because they round up the second decimal point, right? So as soon as you can round up the second decimal point to 5, then they gonna round out the first decimal point. So for example, to show 4.5 on Google Play, you need a rating of 4.45. So if your average currently is at 4.45, you're gonna show 4.5. This is the first difference. The second difference is in the way that the average score is calculated. Apple App Store uses simple linear formula, right? The amount of stars divided by the total amount of, right? So the sum of the stars divided by the amount of ratings, right, that you get, right? So they take the histogram, like how many 5 stars, how many 4 stars, and they multiply, right? The amount of 5 by 5, the amount of 4 by 4, the 3 by 3, and then divide by everything. And this is for your lifetime. I mean, the calculations is lifetime, right? So whatever you achieved, unless you resetted the amount of reviews, it's going to be lifetime. So it's linear and it's easier to predict, to calculate, and everything. Also easier to um, not easier. I mean, much more difficult to recover in the end. Let's talk about the Play Store. The Play Store, I'm going to tell you about the Play Store. You're going to understand the problem with App Store. So the Google Play Store, they actually weight, like they put more weight on the more recent reviews than the past reviews, and we don't know how much exactly. We don't know the formula that they use. Okay, so there is some kind of a decay applied to each review as time goes by. And I don't know what's the exact decay, right? So in this tool, I used like, I think 60 days, 90 days, 120 days, or sorry, 45, 90, and 180. And you can choose whatever you want. I think it's more kind of somewhere between 90 and 80. That's what I think. So after, what it means is that after, for example, 90 days, the weight of a specific review loses half of its influence on the total count, on the total, not count, on the total, like, calculation of the average. And they actually change even the histogram, right? So if you export your histogram of how many 5-star, 4-star, 3 stars you have, like, they change it. It's not the actual number. That's what I figured out while I was doing it. They just they change it to fit the formula, and then they present you the histogram. So this is the difference. And what it means in practice is that it's much easier with Google Play to get hit with a crisis, right? Because they value more the recent reviews. The recent reviews carry heavier weight in your calculation of your average rating score, from which they derive the displayed rating score, right? So if something bad happens, you're going to see it much faster in Google Play. However, it would also be easier to recover, right? Because it works both way. As you start recovering, for example, you had a bad release, you ruined some features, it took you 2 weeks, and then you recovered, so your rating is recovering. So the what happened 2 weeks ago starts getting less and less important, right? So it's also easier to recover. While on Apple App Store, well, it's more robust against crises, but if you really manage to ruin it, so it's going to be more difficult for you to recover. And so to deal with this, I created this calculator, right? So I was using, a piece of paper and a pen, to calculate stuff, for myself, or Excel spreadsheet, anytime that, I was asked about this. And now I wanted to put it into a tool, and allow everybody uh, to use this, to check their app ratings, to be able to predict, how fast they can increase the displayed rating score if they improve the ratings, etc. So let's see how you use it. Okay, I showed you how to get here. Now, for example, let's take an app. Let's take this nice photo and video app, and let's look at what they have. So you can pick a country, by the way, default, of course, US. The app, the store, right? How many ratings, what is the exact rating, and what is the displayed rating? So there are two things. There are calculate rating goal. I mean, for example, if your goal is to go from 4.7 to 4.8, what would it take? Or you can go straight to the stress test. We're going to do this stress test later. So right now we're about iOS. Apple App Store, it's the easiest. So if you go to set your rating goal, the default is going to be just one step higher, right? So if you are at 4.7, I'm going to show you the target of 4.8, and you're going to choose what is going to be the expected average rating score of the ratings you're going to generate, right? So obviously, if you want to move to the next step, you need to have rating that is better than your exact rating right now. Now, if you want to get to 4.8 with this app, it doesn't mean that you need to produce 4.8 like I did here. You can get there by moving your exact average rating to 4.75, right? But so you can change it. You can do this like 4.77. I don't know. But for the example, let's use 4.8. Now, store data. So we know it is the App Store. We know, don't change it to Google Play if you are using it for an iOS app. Current rating count. This is what you have today. Current exact average, what you have today. And then you get this. So if you want to jump one step higher, based on the data that we have now, it will take you 16,000, right? 60,000 something additional ratings at 4.8 to start showing 4.8. But it's a question of the projected ratings over time. This is very important because here, if you have an input, if you know data about your app, so you can add this and it will give you much more accurate result, because you see this number, ratings per day, the average ratings per day. So I calculated by taking your total rating count and dividing it by the age of your app. And then I get per day, like a lifetime average. Obviously, it's not true, and there's a good chance that you are moving much faster today. So you can update this for something more reasonable. You can do it for days or for weeks, right? So let's say you get 30 per day, right? So at 40 per day, it's going to take you, you see, 538 days to get to 4.8. Okay, but if you are at, I don't know, 50 per day, it's going to take you less than a year. But it's a big jump. It's a big jump at 44,000 to get to at least 4.75 with just expected feature rating of 4.8. But if you're expected going to be 485, you can see it's going to take you like less than half of a year, right? 162 days. And here you have a sensitivity. Actually, it does it for you. So it's going to be 8,000 with the expected average rating you put here. But I will add, I will do this sensitivity analysis and show you, it would be much faster if your rating is higher. So just, use reasonable data. Now let's talk about the stress test. And with the stress test, it's really important to use reasonable data, because if I'm just going to invent numbers, I'm going to get weird results. So I already tried it multiple times. So every time I use real data from actual apps, it makes sense. When I start to invent things, it gets more difficult. So try to use reasonable things, otherwise you're going to get weird answers that you're not going to like. So we talk about this app with 44,000 reviews. Let's assume they get 2,000 low rating reviews at 2.2 for 10 days or 14 days until they fix it. Sorry, I need to, not our app, sorry, right? So for 14 days until they fix it, right? So they're gonna drop here, right? The drop is gonna be big, right? So they're gonna move from 4.7 to 4.6, and the average from 473 to 462. Then let's talk about the recovery. So let's assume they recover at 50 per day, and an average of the previous average. They had 4.73. So we can see that it's going to take them 12,000 ratings to recover at this average rate, which is 241 days. Well, quite difficult. That's what I said about Apple App Store. I mean, there are good protections, right? So it's quite robust against those things. If historically you maintained high rating with good volume of reviews, it is robust. But if you are hit hard enough, it's going to be difficult to recover. So here you can see it's going to take you 241 days to recover for a visible displayed 4.7. Obviously, if during your recovery your rating going to be higher than your usual average, like 4.8, it's going to take you less, only 129 days. So this is the analysis you can do. This is what you see. Obviously, then you can also calculate how much will it take to get to a 4.73, which is the average. But I mean, it's only interesting for I don't know, for the management, maybe not for the users. The users only see a displayed rating unless they're sick in their mind, like myself, who going to look at going to extract the data and see the exact reviews. But okay, so, and obviously to recover to exact rating, you see it's going to take you a few years, right? quite difficult. So this is Apple App Store. Welcome. Now let's do an example with Google Play. Let's take this app, big app, almost 500,000 reviews, but this is ratings, but this is not really ratings because we know Google weights this, like they recalculate it all the time. Okay. So this app is Google Play. They have the almost 500,000 ratings. This is the average, 472, pretty good displayed rating. Now let's say they want to get to 4.8. So here's the thing with Google Play. First of all, you have the, again, so this is set the same way. You can change it, but it's always going to take you one step up, right? So one step up from 4.7 to 4.8, and expected average of future ratings 4.8. And you can change it if you think it's going to be less or more. Now, recent ratings per day. Again, so this is calculated based on the average of the lifetime of this app. I don't know how old is the app, but the calculation knows. And I don't know if this is reasonable. Let's try to make it 500. Now, this is the Google Play weight estimate. And here is this decay that I was talking about. So it's called sensitivity here, and start with medium. Again, medium, I think it's 90. I don't remember. So low is 180, medium is 90, and high is 45. So it depends. I don't know what the real decay is. So medium is 90 days. There are some that say that it is not 90, it's 60. I don't know. You need to check, with your own data, what is more reasonable. I think 90 is okay. So I'm going to keep it at 90. 90 days decay. And so here it is. So this is what would it take, right? So in 49 days, if they generate 500 ratings every day, they're gonna get to a displayed rating of 4.8. And they are not very far from there because they are at 472. So they need to go to 474.5, right? 4.745. It's not a lot, right? And also I said that they're going to generate 500 per day. The average was about 200. Maybe it was too much. Let's take 350. And then at 350, it's going to take them 65 days, sorry. Already a little bit more reasonable, right? So this is the Google Play. Now let's do the crisis for Google Play, which is quite difficult. Again, you need to have good numbers, good examples with numbers, so it will make sense. So let's assume they have almost 500,000 ratings. Let's say they're going to have 1,500 poor ratings at this rate, which is half of the average, and it's going to take 10 days. They're going to do it for 10 days, and then they're going to recover at 350 ratings per day at their usual average. And we're keeping the decay, the sensitivity at medium, right? So again, just to explain, so if you do higher, it means that recent reviews has less weight, okay? Right? High sensitivity means recent ratings affect Google Play faster. More weight, obviously. Okay, the effect faster. And low, it means that it takes longer for them to, the older review have more weight. In any way, the new review have more weight. This is why it's not linear. So in any way, it leans to, even the low leans towards the new reviews. The question is just how much. So let's keep it at medium right now. And this is what's going to happen. So in 10 days of this crisis is going to drop. So crisis impact, 15,000 low ratings, averaging at 2.36 over 10 days. The displayed rating moves from 4.7 to 4.3. This is a big hit, right? This is a big hit. Exact ratings move from 472 to 4.3 almost, right? What's gonna take to recover? So the recovery to displayed rating of 4.7 is gonna take like almost 100,000 reviews, right? So almost like 1/5 of what they have currently. It's quite difficult. It's going to take them to 282 days. It's quite difficult. I mean, this is a big hit. Let's maybe do the hit smaller. Let's say the average is going to be 3.75. Good. more reasonable, right? So if these 15,000 negative reviews gonna have an average of 375, it's gonna last for 10 days. They're gonna drop from 4.7 to 4.5 displayed, and then it's gonna take them about 150 days to recover. More reasonable, okay? So if they recover to 473, which is their old average, previous average, it's gonna take like 5 months, right? So, but if they recovered better, like they're gonna recover to 478, it's gonna take like 3.5 months or something like that, right? And this is how it looks, right? So it's not linear. It's quite difficult to see because it looks linear, but it's not linear as with Apple App Store. And if you change to low, right? If you change to low, what happens is that it's gonna be faster, because high means that the recent ratings have play faster, right? So you have more weight, and low means they have less. So low is like uh, 180, right? 180 days. So I mean, you can play with it. You can see what makes more sense for you. Nobody knows the exact formula. You can model this with your own data if you have this. So if it's low, so I mean it's gonna take you only 63 days, right? But also please pay attention, right? With low, it's gonna take you 63 days. It's gonna be faster to recover, and the hit is gonna be more moderate, because again, with low sensitivity, your existing rating is more robust, like with Apple App Store, right? So, but if it's high, if the sensitivity is high, right, it means that this is not robust at all, and the recent ratings are, having an important major effect. So you can see what happens. You don't drop from 4.7 to 4.5 anymore. You drop to 4.4. Okay, you drop to 4.4, and then it takes you here 96 days to recover, right? 96, and here 100. So this is interesting, right? Because we increased to 478, right? So on the one hand, you drop faster, you drop lower, but you fall lower, but you also recover much faster, because again, this 478 is not something you used to have before. You used to have 473, right? So you also enjoy this impact faster. So this is how it kind of works. This is, I think, how you can model it. It's not perfect because it's not linear, and I don't know what they really use. But from the data that I ran on actual cases with actual crises, it looks reasonable. Again, the most important thing to remember also that if you have more reviews, you are more protected. So your best protection is a lot of reviews. Because as I said at the beginning, I don't remember if I said, right? So it takes you, like, if your average rating is 4.5, so one negative review of 1 star, it's gonna take you 7 5-star reviews just to offset the negative impact. And it regardless of how many reviews you have, to offset the impact, gonna take you 7 versus 1. You understand? What helps you, like how the math works in a way that if you have a lot of reviews, so it's still going to take you 7 5-star to offset it, but you're not going to feel the impact. I mean, the impact of this one negative review is going to be 0.00 something. You're not going to see it. So, right, if you would like to offset it, you need 7 5-stars, but you're not going to see the impact. Okay, and this is what kind of protects you. This is the best protection that you can get, is high number of reviews. And when I mean high numbers of reviews, I mean more than you can expect from your average traffic. Okay, you need this number to be elevated, right? So you can look at the average of the competition, and there are some ASO tools that are going to give you this estimate. The Upfigure, I don't use Upfigure, it's not an ad. I don't use it. I used it in the past. Don't use it, but they have this DRP download, also DPR, downloads per review, something like that, downloads per review, kind of a metric of how many downloads an app generates in order to get one user rating. And then you can see if you are above the competition, above your niche, right? So you're in a good position because you are more defended, right? You have better defense against these kind of crises. And this is really, I mean, the only way that you can defend yourself. And obviously you can model, you can, if you think it's going to be a problem, if you can expect something bad happening, you know, so you can model this, you can use this kind of calculator, simulator, whatever. And remember that, with Google Play, it's more difficult and you need to assume a certain level of decay. And with iOS is easier. That's it. Thanks.